Hi KCET 2026 aspirants, welcome back to the Sankalp series. So now let me tell you that in our last class, we have a great introduction, a hi-hello meeting to these magical compounds which can be life-saving drugs because these are present in the medicines that are used to cure typhoid, malaria, goiter, as well as at the same time these are the deadliest pollutants present in the atmosphere. So what are we going to do in today's class? Before knowing that, let me share my experience with the last class. Okay, so last class was the best class because I can see so many comments flooding in the comment section where you people have answered each and every question. You have answered throughout the sessions, you have given scores to yourself, as well as you have answered in the homework sections. That too, majority of the answers were absolutely correct. So these comments really made my day and touched my heart. And these comments and some comments were like this: ma'am, the class was so interesting, we understood everything. So that really made my day, and I was really motivated by seeing those comments. Okay, so I promised in my last class that whoever students comments or give replies in the comment section will be celebrated in the next class. So before talking about what all things we will be studying today, let's first complete this I'll say most important thing, that is congratulating to all of you. I'm really proud of you, and you keep working hard like this. Okay, so first I'll talk about what we are studying today, but let's have a brief applause for all the students who have answered in the last class, and I consider all of them as KCET winners, and I can see that the whole screen will be now filled with all of your comments. So let me just take some names here. So first we have a student here, Sagar Anmol Chopra. So this student has answered each and every question, each and every score he has given. He has answered the homework questions as well. So first of all, a very congratulations and kudos to Sagar. Next we have here Vinod, where he has really praised my hard work. Ma'am, the class was too interesting and I understood as well. So that thank you Vinod, and I'm really grateful that I was able to help you. Next we have Ashwini Ras. Okay, I may have pronounced it wrong, so sorry dear. Homework questions he has given: option number 1 is B, 2 is D, 3 is A. That all of them are absolutely correct. Then we have here Austin. Austin has given so many other answers as well. He has given it different timestamps and the answers, and he has also given a question that I had asked: what is allylic halide? So halogen atom attached to sp3 hybridized carbon next to the carbon-carbon double bond. So the effort the student has made here to write such a big answer, such a long answer, really shows that he was interested and involved in this class, he or she. Next we have here Punit Kumar. He has also answered many questions, and I have taken this particular comment where he have really given a sign that we have done, means he has understood the concepts, he has done the questions. So that really shows that how much involved this child was in my class. Next we have Kumud. He has also answered a question, that is option number D. And we have Viresh here also, he has also answered this question. And yes, Vinod DVMR, I think I have already taken. This child is so honest. He has given option 1 is option number B, 2 is option number A, and 3 is I don't know ma'am. So don't worry Vinod, we will be discussing the third question today in the homework solutions, and then we'll be moving forward with the class. Okay, so students, this was super duper interesting class, and I hope that in this class also the same energy, the same enthusiasm, the same interest should continue. Okay, so in today's class we will be talking more detail about the haloalkanes and haloarenes. So basically we'll be talking how these haloalkanes and haloarenes are prepared, what reagents we use in the lab, what all things we need to mix so that we can prepare them, and slightly we will also talk about their physical properties. Right? So let's enter this class with full clarity, confidence and interest. Okay, let's move. So first of all, I'll be discussing this homework 3 question because that was something was slightly difficult. Slightly I can say tricky question. 4 compounds are there: toluene, orthodichlorobenzene, metadichlorobenzene and paradichlorobenzene. So let me just draw them. You have toluene, you have orthodichlorobenzene, then you have metadichlorobenzene, okay, and then you have paradichlorobenzene. Okay, the first one is toluene, so I should have CH3 group here. Now let's see what happens in this all the compounds. So here we have dipole moment in this direction, so the resultant dipole moment will be in this direction. Here the dipole moment is in this direction and here the dipole moment is in other direction. So here also we will have a resultant dipole moment in this direction. Here we have one dipole moment, here we have an dipole moment. Now you see these two dipole moments are exactly opposite to each other. So if they are exactly opposite to each other, what will happen? They will cancel each other, right? So if they will cancel each other, the net dipole moment will be 0. What will be the net dipole moment? 0. So if this is 0, then what will happen? So this will be the one with least dipole moment. So I should have fourth in the last option. So I can eliminate these two. Okay. Now let's see. Here also we have resultant moment. Here also we have resultant moment. There is no cancellation here. Now you should remember that this one, what I'll say, the dipole moment is proportional to distance, means if the atoms are closer to each other, the dipole moment will be more, right? So if you see here, these two atoms are closer to each other as compared to these two atoms, right? So what will happen here? The dipole moment will be maximum because they are closer to each other. Okay, so I can say that the second one will be maximum. Okay, so here also I can eliminate. So option number A will be my correct answer. Okay, so after fourth, here there is dipole moment is 0. Here there is no electronegative atom, so slightly some dipole moment will be there due to methyl, so that will be the next one. So after 4 I will have 1. These two are really confusing. You should be clear that as the distance increases, the dipole moment will decrease. Okay, so the atoms should have close proximity with each other. So here these are closer to each other, so the dipole moment here will be maximum. So 4, 1, 3 and 2. If this question is clear, please put a thumbs up and let's move to the next today's section. So in the last class we have already met our haloalkanes and haloarenes, right? We have said them hi, hello, we have understood how to name them, how to call them, right? So we have known a brief introduction about all of them. Now today we will know that how are they prepared in the lab, right? So today we will go, so just now all of you close your eyes and imagine that you are in this situation, okay? You are in this lab, you are preparing what today? You are preparing haloalkanes and haloarenes. So yes, today let's prepare haloalkanes and haloarenes, and you all are welcome to this lab, okay, where we are today synthesizing what? Haloalkanes and haloarenes. So first we will start with today's part 2, and today we will be talking about preparation of haloalkanes, preparation of haloarenes and some physical properties. Okay, so let's start with the first one, preparation of haloalkanes. So what is haloalkanes? If you don't remember, just let me remind you, RX, where R is what? Any aliphatic group. Aliphatic group means non-cyclic, a linear chain, branch chain, it is open chain, okay, it is not a cyclic compound. So this is called haloalkanes. Now how can we prepare them? So there are 3 sources from which you can prepare haloalkanes. There are 3 sources from which we can prepare haloalkanes. Very simple, you have to remember. The first one is alcohols, right? We all have used alcohol in some or the other way. You might have used spirit, you might have used deodorant, sprays, these all contains alcohols, okay? So alcohols, using alcohols, how we can prepare haloalkanes. The second one is hydrocarbons. Hydrocarbon means alkanes, alkenes, alkynes, these are called as hydrocarbons. And lastly we will see halogen exchange method, okay? We will discuss this in detail. So now please close your eyes and quickly recall what are the 3 sources. First one is from alcohols, second one is from hydrocarbons, third one is from halogen exchange method. Okay, so now if I see from hydrocarbons, again we have two things, that is, I told you hydrocarbons can be alkanes, alkenes and alkynes. So we can prepare haloalkanes using alkanes and alkenes. Okay, and then for halogen exchange method, we will be meeting two name reactions today. First time two name reactions, Finkelstein reaction and Schwartz reaction. Okay, the name might be confusing, but don't worry at all. I will teach you in such a way that everything is stored in your mind very nicely. We'll do questions, 25 or 20 questions are there in today's class, and I want all of you to put down your scores in the comment section and let's study. Okay, fine. Okay, so in alkenes, we will further see how we are preparing haloalkanes, addition of HX and addition of X2. So this chart everyone should prepare and should be keeping in your mind. This chart is very, very important. If you have this chart, you can easily, quickly, in fraction of seconds, you can revise the entire preparation of haloalkanes and haloarenes. Okay, so first let's move to from alcohols. We know what is alcohols. Alcohols is a compound where we have this OH functional group. Okay, so now what we will do is we will add certain reagent to these alcohols such that this OH group is now replaced with X group. Are you getting what we are doing? We will take alcohol, okay, we will add certain reagents to that, and after that the OH group present here, which was present here, is replaced with now X group. What is X here? X is your halogen, right? X is halogen. So now what is the thing that we have to remember? What are these reagents? What all reagents can be used? Suppose if I want to add chlorine, what all reagents I have? If I want to use bromine, what all reagents I have? If I want to use iodine, what all reagents I can use? Okay, so we will see that. So here I have written all the reactions that is required. Okay, so you have taken alcohol. Okay, first I will insert HCl and ZnCl2. Remember, HCl and ZnCl2. Now what will this do? As I told you, this, what is the X present in this compound? X, the reagent which contains chlorine. So what will happen? Here we will get RCl plus water. Okay, RCl plus water. Now see, you might be thinking what is the mechanism and all. The mechanism for these reactions are not required. It is very in depth. Okay, so if you want, you comment, I will explain the mechanism for each and every reaction, but that is something which is not required for your exam at this point of time. Okay, so that is why we are not going too much detail into the reaction. The only thing we need to remember here is the reagents. Okay, so first of all, first reagent is HCl and ZnCl2. What will that give me? RCl plus water. Now second reagent is NaBr plus H2SO4. Here what is the X you can find? This is the bromine is the X here. So what I will get? RBr plus NaHSO4 plus water. So you can take first one HCl plus ZnCl2, second NaBr plus H2SO4. So we have seen for chlorine and bromine. Next you can, this is very important, PX3 and PX5 or PCl3 and PCl5. Okay, these are very important questions, will be asked repeatedly from here. Okay, so in PX3, if you take, X can be chlorine or bromine. Okay, PCl3 or PBr3. If you take, you will get 3Rx, means you don't have to remember this one. You will get Rx plus H3PO3, Rx plus H3PO3. But if you take PCl5, then you will get RCl plus POCl3 plus HCl. Okay, so let me just repeat it. If you, how will you remember? See, PX3 is there, it's a, there are only 3X, means it's a smaller compound, so we will have only two products. Here we have a bigger compound, PCl5, means 5 chlorines are there, so we will get 3 products here. Okay, so what are the products here? We will get for PX3, you will get Rx plus H3PO3. But for PCl5, you will get Rx plus POCl3 plus HCl. Okay, these two are very important. You must remember these reactions. Okay, very important, these two. Next, what we have, you can use red phosphorus with X2. Here X can be bromine or iodine. Here chlorines are not used. Okay, so you can use red phosphorus with Br2, you will get RBr. Red phosphorus with I2, you will get Ri. Next, we have SOCl2. It will give you RCl plus SO2 plus HCl. Now, this is again very important. Now, remember, this method is the best method. Out of these 6 methods that we have studied, which is the best method? This one is the best method. Can you tell me why? This is because here what happens, this SO2 and HCl, okay, these are both in the gaseous form. So, what will happen? You see, you just imagine, you have taken a test tube. Okay, you have taken this test tube, you have alcohols, okay, then you added SOCl2 to this. In this, what will happen? Immediately this ROH will get converted to RCl, and there will be 2 more byproducts, which is your SO2 and HCl, but these are gaseous products. So, what will happen if they are gaseous products? You know, gaseous products have a very special property that they cannot stay in one place, they will evaporate. So, what means that is this SO2 will evaporate. Okay, they will go out of this container. So, now in the solution what I have? In the solution, you have only RCl. So, you don't have to do anything. Directly if you put, you will get the RX compound, right? You don't have to do any separation, filtration, purification, nothing to do. Everything will be done by itself because these are gaseous byproducts, right? So, that is why this is the best method for preparation of RX. Okay. So, now let's quickly revise all the 6 methods. The first one is HCl plus ZnCl2. Second one is NaBr plus H2SO4. Third is PX3. Fourth is PCl5. Fifth one is red phosphorus with X2, and sixth one is SOCl2. Now, quickly have a screenshot of this one or note it down, because now I am going to conduct a test. Okay, quick test. So, okay, before that I will tell you one more thing, that these alcohols, okay, we have seen what is primary, secondary, tertiary haloalkanes. Similarly, we also have primary, secondary and tertiary alcohols. So, for example, if you see this one, yes, if I have an alcohol like this, now the carbon which contains the alcohol group is attached to only one more carbon. So, this is a primary alcohol. Now, similarly, if I have like this, OH, the carbon which contains the OH group is attached to 2 other carbons. So, this will be secondary carbon. Now, if I see the next one like this, the carbon which contains the OH group is attached to 3 other carbons. So, this is a tertiary one. Okay. So, now if there is like this, that you have given this HCl, ZnCl2. Okay, in this reagent you have HCl, ZnCl2, and you have one primary alcohol, secondary alcohol and tertiary alcohol. Then which one will react fastest to give you Rx? So, that is the reactivity order. 3 degree will react faster, then 2 degree and then 1 degree. Okay, clear? Now, let's welcome. So, I welcome all of you to my lab. Okay, so in this lab, what we are going to do, we are having one test tube where I have, what I have here, we have ROH. Okay, now what I will do is, I will be telling you what compound I am adding here. You need to comment down the product fatafat. Okay, so ready? All of you are ready? If you want to revise the previous slide, go back, revise quickly and come back here. Quick, I'll tell you the 6 reagents and I want the product immediately in the comment section. Let me see how much you have remembered now. I'll just repeat once again. We have just 6 methods: HCl, ZnCl2, NaBr, H2SO4, PX3, PCl5, last 2, what is there? SOCl2 and X2 red phosphorus. Okay, so this is my reagent, this is alcohol. I'll put one reagents and you will be telling me what will be the products quickly. Okay, so let's start. So First let me add X2 or yes, first let me add Br2 with red phosphorus. This is my Br2 with red phosphorus. What will be the product? Quickly comment down. Okay, 2 seconds. 1, 2, 3. I'll give you 5 seconds. 1, 2, 3, 4 and 5. So here the product will be RBr. Right? Next let's start. We have done with 1. Next, if I do, to tell me if I add NaBr with H2SO4, what I will get? Again here I will get RBr. Okay, let's do next one. Next one, let's add something. Next one, if I add here HCl plus ZnCl2, what will this give me? Quickly comment down. Quickly comment down here. That will give me RCl. Right? Next, 2 is very, very important. Very, very important. Here, if I give you PBr3. Remember, I told you PBr3 and PCl5. Very, 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 very important. So, what is PBr3 will give me? Quickly comment down. Quickly comment down. Quickly comment down. It will give me RBr plus H3PO3. Right? Have you commented? Okay. Now, if I change this and if I add PCl5, what will be the product? Please comment down quickly. With PCl5, what product we will be getting in this container? What will be the product now? Yes, you are absolutely correct. It is RCl plus POCl3 plus HCl. Yes. Now let's add some more. Last reagent I want to add, which is the very favorite, very, very good student here, very, very good person here who does everything on time, SOCl2. Our favorite reagent should be SOCl2. Why? Because it gives you directly the purified product. So what will this give me? This will give me RCl plus SO2 plus HCl. 1, 2, 3, 4, 5, 6. Yes, all the 6 reagents we have used. So this is my lab and I hope you have enjoyed creating RX in my lab. Okay, so now we will be directly jumping to quiz time. Okay, so in quiz time there are 5 questions here in this particular section. 5 questions are there. You need to answer each and every question, and at the end of the 5 questions you have to put down your scores. Okay, let's move to the first question. The best method for preparing alkyl chloride is, so I told you already which should be the best method here. ROH plus SOCl2, ROH plus PCl5, ROH plus PCl3, ROH plus HCl with anhydrous ZnCl2. So I know everybody could have answered this correctly without any doubt. The answer for this one is ROH plus SOCl2. Reason is very simple, because it gives you gaseous byproducts, right? I hope I don't have to explain this again. SO2 and HCl are the byproducts. These are gaseous byproducts. So once they are formed, immediately they escape out and we are left with our favorite RCl. Okay. Fine, let's move to the second question. Which of the following is the preferred reagent to convert alcohol into alkyl chloride? Again, preferred reagent means you have to select the best reagent that is available. Will I select PCl5? No, it will have a byproduct of H3PO3. Will I select PCl5? No, here also I have byproduct. What is that? POCl3 plus HCl. Again, I have to separate and a lot of work is there. Will I do HCl? No, that will not work at all. Can I use SOCl2? Yes, if I use SOCl2, the byproducts will evaporate here and I will have pure RX or RCl. Okay, next. So I hope 2 questions, same answer, all of you would have answered it correctly. 3 more questions to go for the first round. So select the byproduct formed in the reaction. Okay, now you have to be more worried about the byproduct. You have ROH plus PCl5. I told you this is very important reaction. PCl5. There are 5 chlorines, so we will have more products. So RCl, then you have POCl3 plus HCl, right? So that is your option number A here. Now let's move to the next question. In the reaction X plus PCl5CH3CH2Cl plus POCl3, X is what? So the question is asking about the reactant. So basically we know that what was the source in this particular one? That was your alcohols, right? So alcohols should be one X. So is it ethanol, ethane, ethanol or methane? So it is definitely ethanol because here we have alcohol, right? Ethane is CH3CH3, there is no alcohol here. Ethanol is aldehyde, this is also having no alcohol, and methane is CH4, there is also no alcohol here. So option A is the correct answer here. Last question, and I hope, the answer I have already shown here. Fine, this question I have already given the answer. So fine, let me just discuss this question, but this is an important question, okay? So here everyone will give you grace mark, okay? You have to give your 1 mark to all yourself. During conversion of isopropyl alcohol, okay, to isopropyl iodide, okay, this is a secondary alcohol. Which of the following is not used? This is again important, not used. Is it NaI, Ki, NaIH2SO4 or HI? So basically, if you see, you need one I minus here, okay, something which can give you I minus, and this I minus will be reacting at this particular position, right? So if I take NaI, I will get Na plus and I minus. If I take Ki, I will get K plus and I minus, H plus and I minus. But here what happens? If you take NaI and H2SO4, remember H2SO4 is a very strong oxidizing agent. So what it does is, it oxidizes this I minus to I2. Okay, so in the presence of H2SO4, the I minus is converted to I2. Now I2 cannot react. What should be reacting? I minus. So that is why C will not be the answer here. NaI plus H2SO4 is not used because H2SO4 oxidizes Hi to iodine and water. Okay, so this reduces the availability of Hi, hence this combination is avoided. Okay, so I hope this is clear. So out of 5, everyone will get 1 mark. From the rest 4, how much you are getting, you need to comment now. Okay, let's see who gets 5 out of 5 in the first round. Okay, now we will go to the second method of preparation, that is from hydrocarbons. Okay, so the first one was from what? From alcohols. Under that we have 6 methods: HCl, ZnCl2, NaBr, H2SO4, PCl3, PCl5, SOCl2, red phosphorus and X2. Okay, now we will see the second source from where we can prepare, that is from hydrocarbons. Okay, in hydrocarbons again we have 2 hydrocarbons that can be used. The first one is alkanes, and we will also prepare from alkenes. Okay, so alkanes, how we can prepare? So I'll give you directly the reaction. Okay, so what happens here is, if you take any alkane and chlorine in presence of UV light or heat, what will happen? Whatever hydrogens are possible, all the hydrogens are replaced here. Like for example, if I replace this hydrogen, I will get this product. If I replace one hydrogen from here, I will get another product, right? So we will get both the products there. Okay, so this one will be your 1-chlorobutane, and this one will be 2-chlorobutane. Now you might be thinking, ma'am, why not about this hydrogen and this hydrogen? So if you replace this hydrogen, again you will get 2-chlorobutane, and if you replace this hydrogen, again you will get 1-chlorobutane, right? It is the same product form. So this is why what is happening here, you are seeing that we are getting a mixture of products. You are getting 2-chlorobutane also, 1-chlorobutane also. So that is why this is not a preferred method. Now what is this method actually? This is free radical chlorination. The mechanism used here is free radical, means radicals are formed here. So let me just explain you what happens. When you take chlorine in presence of UV light, you get chlorine radical, means this bond breaks here and you get chlorine radical. Now similarly, if you see here what happens, if I just write like this also undergoes cleavage, and we get a double bond, we get a radical here. Now what will happen? This Cl dot will attack on this one, and you will get a compound like this. Okay, you can also, this cleavage can also happen here, so this chlorine can attack here and you will get the second product, right? So what basically is happening, we are not getting a single product in this, we are getting a mixture of products. So that is why this method is not a good method. Okay, this is not a good guy, we should be avoiding this method. Why? Because it is giving so many products, it's confusing us, it is not giving us a single product like our best friend SOCl2. Okay, so you can see free radical chlorination or bromination gives a complex mixture of isomeric mono and polyhaloalkanes. Okay, so this can also happen that all the hydrogens are removed. So if the reaction continues, you can get so many types of products from here, which is difficult to separate as pure compounds. Consequently, the yield of any single compound is very low. Okay, so that is why this is not a preferred method. Okay, but if in the question it is asked that out of these two products, which is the major one? So always remember 3 degree, then 2 degree, and then 1 degree. Okay, so this, if you see this one, this is a chlorine, the carbon containing the chlorine is attached to only one carbon. So this is my primary, and the carbon containing the chlorine here is attached to 2 carbons. So this is secondary. So which will be major product? This will be the major product. Getting? Okay, so from alkanes we have seen, but we found okay, alkanes are of no use, means the method is there, but that is not a good method. Now let's see about the next compounds, that is alkenes. Okay, so in alkenes we have again two things, addition of HX and addition of X2. So first we will see from alkenes addition of HX. Now I have put a scientist's photo here. May I know why? Anyone can guess? Can you just guess who is this scientist, or what is the reason of putting here this scientist photo? Let me just give you 1 minute time to think about quickly. Can you recollect anything related to addition of HX and this scientist here? Oh, sorry, just a minute. Yes. Can we do anything here? Okay, I'll give you a hint here. The scientist's name is starting means it has a full name, but the name which we are more acquainted is M. M for M. It starts with M. Anyone can guess here? Please put down in the comment section. Your time is ending now. 3, 2, and 1. Okay, the scientist's name here is Markovnikov. Okay. And why I am telling this? Now I think many of you would be relating it, because whenever we add HX to an alkene, we follow something called as Markovnikov rule. Now what does this rule says us? So let's see it quickly. This rule says that the negative part, okay, is attached to the carbon with less number of hydrogen. The negative part is attached to the carbon with less number of hydrogen. Will you remember this law with a rule? Markovnikov's rule says that the negative part will be attached to the carbon having less number of hydrogen. Or you can simply remember Markovnikov rule, less number of hydrogen. Markovnikov rule, negative part, less number of hydrogen. Markovnikov rule, negative part, less number of hydrogen. Quickly note down and put down in the comment section so that you will never ever forget this rule. Markovnikov rule, negative part, less number of hydrogen. Markovnikov rule, negative part, less number of hydrogen. Please write down in the comment section. Quickly write down in the comment section so that you can remember this rule forever. Okay. So now if I have, so now I told you, so what are the 3 words we have to write? We have to write Markovnikov rule. You can just write down M rule. Okay, Markovnikov rule, negative part, less number of hydrogen. Okay, if I remember this one, if you just put down this much in the comment section, you will never ever forget this rule. I'll guarantee you that. So what does this rule says that whatever is the negative part, that will go to that carbon which is having less number of hydrogen. Okay, if there is same number of hydrogens on both the side, then that doesn't matter, then you can put to any carbon. But if there are two carbons which is having, one carbon is having more hydrogen, another carbon is having less hydrogen, the negative part has to go to the carbon having less number of hydrogen. So here if you see, this is the negative part. Let me take a red ink. Yeah, so this is my H plus and this is I minus, so this is negative part. So this will go to the carbon having less number of hydrogen. Now let's assume this double bond here. This carbon is having one hydrogen, this carbon is having two hydrogen. You can see here, carbon having one hydrogen, carbon having two hydrogen. You don't have to see anything about this hydrogen, okay? Only the double bonded carbon you have to consider. So where will this I go? Negative part, less number of hydrogen, means this I will go to this carbon which is having less number of hydrogen. So that means the product formed here will be this one, and you will also, so I can also go here, but majority of I will go here. So this will be the major product and this will be where I attaches here will be your minor product. Okay, there is something also called as anti-Markovnikov's rule. Okay, so anti-Markovnikov's rule, if you know Markovnikov's rule, then anti-Markovnikov's rule will just be opposite of that. What will happen here? Negative part, okay, goes to the carbon with more number of hydrogen. But here something very interesting part is there which is easy for you. You have only one example of this. So whenever you have any alkene, okay, whenever you have any alkene, and if you have this particular reagent HBr peroxide, okay, this peroxide can be written as H2O2 as well. So if you have HBr with any peroxide, okay, HBr with any peroxide, then only anti-Markovnikov's rule will be followed. If you have HCl with peroxide, HI with peroxide, that will not matter here. Okay, clear? So let's go to the next one, that is addition. Now I'll show you a very nice video after this. Okay, so addition of X2 is there. That is also from alkenes. So from alkanes we have one method, from alkenes we have two methods. One is addition of HX, where we studied about Markovnikov's and anti-Markovnikov's rule, and next one is addition of X2. This is very simple. You have addition of X2, means what, you have to simply use X2 with CCl4, the double bond will break and to both the carbons the halogen is attached. Now two adjacent carbons having halogens is called as your vicinal dihalide, which we have studied in the last class. Okay, so here also something very interesting I have to tell you. In the laboratory, okay, let's go back, let's imagine that we are in the laboratory. I'll take you to the laboratory now. Okay, addition of bromine in CCl4 to alkene results in the discharge of the reddish brown color of the bromine. So generally what happens, this bromine is reddish brown in color, but if you add it to any alkene, okay, the brown color of this one gets discharged, means it loses its brown color, and that is a positive test. Means for example, suppose you have here one alkane, okay, and here you have alkene. Okay, you added Br2 solution here and Br2 solution here. So where will this bromine is actually brown color, reddish brown. Okay, so what will happen, this bromine color will decolorize here, but here the color will retain. So from that we can know where the alkene is present. Here there is still the color of brown color only is remaining, so that means this is not an alkene, and here the brown color is disappearing, that means it is an alkene. Okay, so I'll show you an experiment here. Okay, just a minute. Now let me show you one experiment where I will show you how we can actually test the presence of an alkene here. Okay, so here I have a diluted solution of bromine water. So you can see its color is slightly light yellow, okay, not very bright, but here this one is a concentrated solution of bromine water. So as a result of which its color is lightly bright yellow. Okay, now what we can do is we will be checking these the concentrated one in this particular solution, and we will see that how exactly whether the color is changing or not changing, or what is the result we are obtaining. And what solution I have taken here, in this the solution that I have taken is a alkene group, means a double bond is present in that particular compound. So let's wait and see here. Now we can see this one I will be adding to this particular test tube which contains an alkene. Okay, so we will see the changes that is observed in the color of the bromine water. So please check now clearly the color of this bromine water. It is a bright yellow color, or you can see a reddish brown, something a yellowish reddish brown color substance is present. So now let's just simply open the test tube, open the knob of this test tube and add the solution to this one. Okay, so it's just a 1 minute video, you can just see quickly. We have added the bromine solution to this particular solution where we had alkene group. Now what we are going to do, we will just shake it a bit so that the solution is mixed properly. So now when you see, when you mix it properly, when you just shake it for some time, just let's observe it what is happening. So you can see slightly the color will start disappearing. Okay, it won't disappear at the same time, but it will take some time for the reaction to happen. For the bromine here, what exactly is happening, the bromine present in the Br2 is getting attached to the alkene. See now exactly what has happened. It has become completely colorless. This yellow color has now become colorless. Why? Because the Br2 that was present, that has now attached to both the carbons, right? Now there is no more presence of Br2. Now in this solution we will add what we have taken here. We have taken one alkane solution. Okay, means there is no double bond here, it is a completely single bonded compound here. Okay, so now let's add some bromine water to this compound, and now if you shake it, okay, so what should we observe, that if it is an alkane, there should be no decolorization of the bromine water. Okay, so you can still see that the color remains yellow even after shaking it. The color does not change here. So what does it indicate us? That this is an alkane, whereas this one is an alkene or an unsaturated compound. This decolorization can happen even if in the presence of alkynes. Okay, double bond, triple bond, both will happen, but here you can see that the color is not decolorizing, it is still remaining as the yellow color. Okay, so that was the experiment. So here I would like to stop this one. Okay, and we will be moving to our next slide. Okay, just a minute. Yes. Okay, so now we have understood the addition of the reaction of hydrocarbons, addition of HX, addition of X2, and with alkanes we have to use free radical mechanism. With that I have again 5 questions for all of you. So get ready and you need to put down your 5 answers quickly in the comment section. Okay, and at the end score also. Name the major product when 2-methyl propane is heated with bromine vapors in the presence of sunlight. So you have what? 2-methyl propane. Sorry, I have this one. I'll write it yellow color. Yes, 2-methyl propane. I have very good questions here. So now see, what all hydrogens I can replace? I can replace one hydrogen here and one hydrogen here, because these 3 hydrogens, if I replace any one of these 3 types of hydrogen, that will give me same product, right? So one product I can get from here and one product I can get from here. So if I replace this hydrogen, then what I will get? CH3, CH3, CH2, Br and then H. If I replace this hydrogen with bromine, what I will get? CH3, 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 and here you will have bromine, right? So what is the product here? You have 1-bromo-2-methyl propane, and here you have 2-bromo-2-methyl propane. Now this is a which degree bromine? This is a primary degree bromine. Why? Because the carbon which contains the bromine is directly attached to one carbon. Now what about this carbon? This is a tertiary one. Why? Because the carbon which contains the bromine is attached to 3 other carbons. So now what happens? This one, this 3-degree bromine, I always told you that the majority product will be a 3-degree one. So that is why here we will have 2-bromo-2-methyl propane, which is option number A. Okay, let's move to 7th question here. This is again a very important question and a good question. The number of possible enantiomeric pairs that can be produced during monochlorination of 2-methyl butane is. So you have 2-methyl butane, okay? Yeah, 2-methyl butane. Okay, so now the question is giving possible number of enantiomeric pairs, means you have to see that if you chlorinize them, okay, you have here H, you have CH3H, you have CH3, and here you have 1H. Okay, so if you replace any of these hydrogens with H, are you getting a chiral compound? Chiral compound means after replacing any one hydrogen with bromine, you should be having one such carbon which is having 4 different groups attached. Let me repeat. What you have to do? You have to replace hydrogen with bromine. After that, what should you observe? You should, after doing this, you should have one carbon which has 4 different groups attached to it. Okay, you can replace only one hydrogen with bromine because it is given you monochlorination. So not bromine, sorry, it is chlorine. Okay, clear? Now let's try. So if I replace any one hydrogen from here, so what will be my product? I will get here CHHCl. Okay, so can I find any carbon after replacing this which is having 4 different groups? This carbon is having 2 hydrogens, so they are not different. This carbon is having 2 hydrogens. This carbon is having 2 methyl groups, so that is also not different. So this chlorine is not an enantiomer, so I will keep it back. This hydrogen will not work. Okay, let's think if I replace any one hydrogen here. Okay, so I will replace this one with chlorine. Now can I find any carbon with 4 different groups? I think yes. See, this carbon is one side it is having hydrogen, one side it is having chlorine, one side it is having methyl, and this side it is a different group present here. So definitely this replacement will give me an enantiomer. So till now I have found one compound. Okay, so let me keep it back. We will try with other carbons also, right? So I'll keep CH3, this is CH, and then CH. Let me just write down with yellow. Yes, so I have CH3. I have found one H here. This was H, and I have, so this white H what I have written, if I replace this or this any one of the hydrogen, I'll get one enantiomeric pair. Now let's talk about replacing this hydrogen. So if you replace this hydrogen with chlorine, will you get a carbon which is having 4 different groups? Let's see. So this carbon, one side it is having CH3, one side it is having CH3, one side, so both the side it is CH3, so that is not different here, right? So we will not have this one also. Next, I have seen that if I replace here I will get, if I am replacing here I am not getting. Any other can I find here? Let's try with another one. We have one more hydrogen here, right? So let's replace that. Okay, so what I will do is I will keep this as hydrogen. Okay, this is the hydrogen. Here I have CH2 and one another hydrogen is I am replacing it with chlorine. Now let's see, do I have any carbon which is having 4 different groups? So I think yes. If you see now this carbon, one side it is having H, one side it is having CH3, one side it is having CH2CH3, and one side it is having CH2Cl. Four groups attached to this carbon are now different. So yes, this is also one enantiomer. So if I replace this hydrogen and if I replace this hydrogen, I will get enantiomeric pairs. So that is why the answer here will be option number 2. Now let's move to the next question. Propene on treatment with HBr gives you. This is very simple question. Propene is there. Quickly answer, students. We have propene here with HBr. What will happen? HBr simple is given. Markovnikov's rule, negative part will go to the carbon having less number of hydrogen. So negative part will attack here. So you will get like this. Okay, you will get this product, that is 2-bromo propane. So we have, okay, what is the name of this compound? This is isopropyl bromide, that is option number A. So common name is very important because we have studied in the last class. We can know that 2-bromopropane is nothing but isopropyl bromide. Next, moving to question number 9, addition of HI in 2-methyl-but-1-ene. So we have 2-methyl-but-1-ene, right? Addition of HI. Here I have 2 carbons and here I have no carbon. So the negative part means I minus will go to the carbon having less number of hydrogen. So what will happen here? Here I will have I and here we will have CH3. Okay. So so what is the product formed here? You should have one carbon which is having iodine and methane attached to itself. So if you see this one, the first one, here we can see iodine and methane are attached to different carbons. Here if I see this, you can find this particular carbon which is having methane group as well as iodine group, right? 1, 2, 3, 4. On the second carbon we have methane and iodine. So that is why B is the correct answer here. The last question of this particular segment, you all have to answer them. Which of the following reactions is anti-Markovnikov's addition? Okay, let's see. First of all, HBr and peroxide is given. That means the Br should go to the carbon having more number of hydrogen. So here bromine is having more number of hydrogen, so it should attached here. But bromine is attached here, so this is following Markovnikov's rule, so that is wrong. HBr peroxide, here bromine goes to this carbon. Yes, the carbon having more number of hydrogen, so this is anti-Markovnikov's rule. With HCl there is no peroxide effect or no anti-Markovnikov's rule. I told you only in the presence of HBr and peroxide this will happen. So yes, this is also wrong. So we have option number B here. So 5 questions are over here and let's put down the score here: 5 out of 5, 4 out of 5, 3 out of 5, 2 out of 5 or 1 out of 5. Fine. Now we'll go to the last method of preparation of haloalkanes, that is halogen exchange method. This is very simple. We have 2 name reactions here, Finkelstein reaction and Schwarz reaction. Now according to Finkelstein reaction, what happens? You can take any haloalkane, generally RCl or RBr, treat it with NaI, okay, and then that will give you Ri. So to prepare iodoalkanes, we have Finkelstein reaction, and to prepare fluoroalkanes, we have Schwarz reaction. Here also you have to take any Rx and you have to take one metal fluoride. Okay, what all metal fluorides you can take? AgF you can take, Hg2F2 you can take, COF2 you can take, or SbF3 you can take. So any Rx with metal fluorides will give you Rf, and that is your Schwarz reaction. Any metal halides with NaI, and here we have to use something called as dry acetone. Okay, this will give you Ri. So for iodoalkanes we have Finkelstein reaction, for fluoroalkanes we have Schwarz reaction. So let's do some quizzes here from here. Which of the following is the correct method of preparation of methyl fluoride? So in fluorides what we have, quickly answer. Here I have 2 questions, only 2 or 3 questions. Can I use HF? No. HF? No. F2? No. AgF? Yes. Metal fluorides we have to use, so option number D. Next, the best method to prepare fluoroethane is, okay, so you have taken alcohols. So can we prepare fluoroethane from alcohols? No. Alcohols? No. I have C2H5Cl and Hg2F2. Yes. Here I have taken fluorine and HNu. No. So I have option number C here. Okay. Next, RCH2Cl with Ki acetone gives you RCH2I. The name of the reaction is. So I've just discussed for as for preparation of iodoalkanes we use Finkelstein reaction, whose answer will be option number B here. Okay. So that's all in this preparation of haloalkanes. Now we will move to preparation of haloarenes. What is haloarenes? You have a benzene ring and then you have a X group attached here. This is called haloarenes. How can we prepare them? So for preparation of haloarenes, again we have 2 important sources. The first one is from hydrocarbons and the second one is from amines. Amines means we generally talk about this amine. With benzene ring there is one NH2 group attached. This type of amines, you have to remember the name is aniline. The common name is aniline. Okay. And here from hydrocarbons means simple benzene is the starting material. Okay. So let's see here. The first one from hydrocarbons, you take any group and you just treat it with X2Fe dark. Here X2 can be Br2 or Cl2. Then what will happen? This group will be attached at the ortho position and at the para position. Okay, so you should remember that this CH3 group is an electron donating group, right? It has plus I effect, it donates electron to the ring. So if there is an electron donating group, it will be always ortho para directing. Means if already one substituent is present and that substituent is a ortho para directing substituent, then the incoming group will be attached at the ortho position and at the para position. Okay, now here something interesting we should know, that the ortho and the para isomers, how will you separate them? Can be separated easily by steam distillation, okay, because they have a huge difference in their melting point. So you can easily separate them using steam distillation. Okay, now in this method we can use where X is only what? Chlorine and bromine. You cannot prepare iodine or you cannot prepare fluorine here. The reactions with iodine are reversible in nature, okay. So that is why, and require the presence of an oxidizing agent like HNO3 or HiO4 to oxidize the Hi formed during the iodination. So what happens during this reaction? There is HX is also produced, and that can reverse back the reaction. If Hi is present, it will reverse back the reaction. So we also need to have an extra oxidizing agent like HNO3 or HiO4 which can oxidize that Hi produced in this reaction. Okay, let me just repeat it. What happens here is, in this reaction the byproduct is HX, okay, means HCl, HBr. Similarly we can have Hi also, but Hi is something which will reverse the reaction. To remove this Hi, you need to have strong oxidizing agents like HNO3 or HiO4 which will convert this Hi to I2. Getting? And we cannot prepare fluorocompounds, are not prepared by this method due to the high reactivity of fluorine. Okay. Next we will see from amines how we can prepare. So we have aniline, okay. So from aniline you can just convert them to benzene disonium chloride. Okay, how to do that? You have to use NaNO2 and HX. So that will convert this to N2 plus and X minus. Okay, this is benzene disonium chloride. Very, very important compound. Now in this benzene compound, if you use Cu2X2 or CuX, okay, so that will convert whichever X you have taken here, that will replace this N2 with that X group. Okay, and the byproduct produced here is N2. Okay, so now if I see this part, replacement of the disonium group by the iodine does not require the presence of cuprous halide and is done simply by shaking the disonium salt with potassium iodide. So you can just, if you want iodine in presence of this one, you can simply take Ki for that. You don't need copper salt as a catalyst here, but for chlorine and bromine you need copper salt. Okay, now let's do some quiz here. Arenes means the haloarenes or arenes when treated with chlorine or bromine in presence of Lewis acid as a catalyst undergo dash reaction. So this you have to understand. When you take this one, okay, and you have taken Cl2 and FeCl3. So what will be the product formed here? Here the product will be, when these two will react, you will get Cl plus and FeCl4 minus. Okay, now you can see here we have double bond which attacks on this one. So what is this? Is this an electrophile or nucleophile? This is electron deficient species. You can see a plus charge here. So this is an electrophile, right? So the reaction here is electrophilic substitution reaction, means the hydrogen present here is replaced by one electrophile. Next, let me show you next question. Which of the following catalyst is used in the preparation of chlorobenzene by Sand-Meyer reaction? Now what is the Sand-Meyer reaction, ma'am? This reaction is called as Sand-Meyer reaction. Okay, please note down. So what is we have used? Copper salt we have used. Okay, so let's see this question. So can I use CuCl HCl and CuBr HBr? Yes, we can use. So we have both A and B, which is option number D here. Okay, next the question here is product P and QR. So first of all you have NO2 and Br2 and Fe. So here NO2 you should know is a is a electron withdrawing group, so it is a meta directing group. So what will be P here? The bromine which will be attached at the meta position. Okay, so P will be meta bromo nitrobenzene. After that, when you do SnHCl, this NO2 gets converted to NH2. Okay, so you will get meta bromo aniline. Okay, so when you treat it with SnHCl, what will happen? This NO2 group gets converted to NH2 group. Okay. Now we will have 17th question. Presence of which reagent will affect the reversibility of the following reaction and change into an irreversible reaction? So if you remember, if HI is present, that has to be oxidized, and that can be oxidized by concentrated HiO3, okay, or HNO3. So option number C is the correct answer here. Next, we'll talk about the physical properties. So first of all, there are melting point. So when the mass of the substance will increase, the melting point will increase. If the mass is less, the melting point is less. Okay, that is the basic thing. Density increases with the increase in the number of carbon atoms. As the mass increases, the density will also increase. Next, solubility. Solubility is, it is less soluble in water. Why it is less soluble? Because the solubility means it is actually a non-polar compound. Okay, so it is not soluble in water because water is a polar compound. In solutions chapter, we have studied polar dissolves polar, non-polar dissolves non-polar, right? Similarly, you have more solutions in the organic solvent. Okay, in organic solvent which is non-polar, it is more soluble. Next, solubility decreases with the increase in mass. So if the mass will increase, the solubility will decrease. Clear? Now let me talk about something. Now let's talk about boiling point. Okay, boiling point is from where maximum questions will be asked. So my students should be very thorough about boiling point. Okay, so boiling point, you should know, it is directly proportional to mass. Means if the size, if the mass of the compound is going bigger, the boiling point also goes increasing. Okay, and it is inversely proportional to branching. What does that mean? For example, if I take a compound which is a straight chain, okay, the same molecular formula, you have a branch chain. That means the straight chain will have more boiling point than the branch chain. For example, you have suppose butane, okay, the formula is C4H9Cl. Right, suppose this is the compound 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the compound, okay. So it is a straight chain compound, and here we have a branch chain compound. Okay, so in this case, what will happen? The branched one will have less boiling point than the straight one. So always first you have to check mass. If the mass is same, then you have to check the branching. Okay, I hope you have got this. Now let's solve some questions on this time, and this is the last quiz session, and here we have 3 questions for all of you. So 3 out of 3, who is getting? Let's see. So which of the following is liquid at room temperature? So how will you decide whether it is liquid or solid or gas? So listen, if the mass is more, okay, if the mass is more, then there will be more interactions and the compound will be in the liquid state. Okay, so you can see here fluorine mass is less. Here you have 1 carbon, here also 1 carbon, here also 1 carbon. Here you have 2 carbons, but iodine mass is very high. Okay, so mass is more, that means more attractions, it will remain in the liquid state. So option A is the correct answer here. Next we have 19th one, the decrease in the order of the boiling point, CH3Cl, CH3Br and CH3F. So what you have to check here? Mass, right? More is the mass, more will be the boiling point. So bromine is the one which will have the maximum mass, because we know the mass order is fluorine, chlorine, then bromine and iodine. So bromine will have maximum mass, so eliminate these 2. After bromine we'll have chlorine here. Here I have chlorine and here I have fluorine. So I'll eliminate this one. Option D will be my answer. Next, 20th question. Alkyl halides are immiscible in water though they are polar because. Okay. So alkyl halides, what happens? They are less miscible in water because they react with water to give alcohols? No. They cannot form hydrogen bonds with water. CX bond cannot be broken easily. They are stable compounds and are not reactive. Yes. So whatever, for solubility, we need hydrogen bond formation, okay, but these compounds are unable to form hydrogen bonds, and that is why they are non-polar compounds. Okay, so sorry, since they are not able to form hydrogen bonds, they are insoluble or immiscible with the water. Okay, so option B is your correct answer. And I think by mistake I have mentioned here also that Rx is non-polar, so please forgive me. Rx is a polar molecule, okay, but still it is less soluble in water. Why? Because absence of hydrogen bonding. Okay, I have told wrong here by mistake, so please correct it. Okay, so my bacha log, we are done with the today's class, and now what is the time? Homework time. Okay, so like last class I have given you 3 questions, question number 1, question number 2 and question number 3, based on what we have studied today. So if you have watched the complete lecture, understood it very well, then you should be able to answer all these questions in the comment section, whether it is correct or wrong. Please do answer, and I want participation like last class. Everyone should be putting their scores, should be putting their homework questions and the answers. Okay, so that's my request, and that is something will help you to improve in your chemistry. I know organic chemistry is little bit bulky, little bit difficult, but if you study with me regularly, you will master it. I guarantee you that. Okay, so my bacha log, my children, please take care of yourself, keep smiling, keep learning. Bye bye, and see you soon in the next class.